So we have this spending multiplier, and I want to go ahead and give it a formal name and definition. We formally call this the expenditure multiplier. The expenditure multiplier shows that the change in long-run real GDP is greater than the change in initial spending. Again, the expenditure multiplier shows that the change in long-run real GDP is greater than the change in initial spending. Okay, so we got the definition. We'll put a formula up here in just a second. Let's talk about the story. So our firms have increased investment spending by $1,000. It's probably not a super realistic amount, but that's okay. So how might we see an increase in investment spending? Well, one way is if a firm builds a factory. So a couple of years ago, a few years ago now, IKEA built a big giant building right next to Sloot. And they engaged in some form of investment spending. Again, pretend it was $1,000. It wasn't. So they engage in $1,000 of investment spending. They're paying out to have that factory built. Well, who's building it? Well, workers, right? There's workers who are receiving an income. They're going to take that income and presumably they're going to spend that income, which means not only did investment go up by $1,000, we're going to see consumption go up because our workers, if they're getting paid more income means more consumption. Right? We talked about that relationship between Y and C. Let's see, who else gets more out of that? Actually, the government. Because our workers are now getting paid, they get a paycheck, the government gets their share. And what is the government going to do with their share? Well, they're going to spend it. They're really good at that. So all of a sudden, investment went up. That caused consumption to go up. That caused government to go up. And I don't think it stops there. I think it kind of keeps trickling through society. Because those workers, where are they spending the money? I bet you some of them probably bought lunch at one of the surrounding fast food places, right? So maybe they went to rallies. I don't know why they would go to rallies, but maybe they went to rallies and they bought food there. Well, rallies is seeing an influx of business. They were a lot busier when that construction went on. What would rallies do? Probably hire another worker to kind of work that midday lunch shift, maybe another 2 workers, which means that they're spending money. Firm spending is rising again. They're going to pay those employees, which means those employees will have an income, and they're presumably going to spend it. Consumption's going to go up again. The government is going to get taxes from rallies' new employees, and they're going to spend that money. So spending goes up again. And this kind of has a chain reaction all through society. So that one spending change, it doesn't matter in what component we started in, is going to have this chain reaction through society that shows that all of our other expenditure components are going to start going up as well. Right? So while I said I was plus 1,000, what I have to do to one side, I have to do to the other, I left off part of the story. Well, if I goes up, that's going to cause, well, C to go up. And then G is going to go up. And then, maybe I goes up again to account for the new consumption, and then those workers get paid. And, the government gets paid there. And honestly, maybe even net exports change. People might order more imports or might use their business to sell off it. So this is probably going to change in some measure as well. So one spending component change has that chain reaction effect where all of our components start changing in value. And the end result, that definition for expenditure multiplier, our change in real GDP, this difference in Y, is going to be greater than our change in initial spending. So we clearly see that in this case, the economic growth exceeded 1,000. Is there a way to determine this? Just like we talked about last time, we don't want to add up every single sector through all time. That's going to take forever. We want to use a multiplier formula. So we have an expenditure multiplier formula. that shows the change in real GDP is equal to 1 over 1 minus the MPC times our change in spending. One over 1 minus the MPC times our change in spending. Right, we still want to be able to capture the slope of our aggregate expenditure function, so we know we have to have it in there. Again, MPC recorded as a decimal. So let's continue our example, right? So our example was that our change in spending was 1,000. Let's just make up an MPC, 0.6. And I did that for, all I did is for easy math because I can do this in my head. So if I apply that in this formula up here, I would have 1 over 1 minus 0.6 times 1,000, which reduces out to 1,000 over 0.4, which equals 2,500. That is my change in Y. That is my change in Y. That is not the value for Y. I'm not finding real GDP. I'm finding how did real GDP grow. I'm finding the distance from Y1 to Y2. So this distance from Y1 to Y2 is plus 2,500. Actually, that kind of looks scaled okay. That's pretty good. I'm actually kind of impressed with the art. So it kind of worked out. So we expect to see that expenditure change in society. This also gives us a quick indication now of how our model will change. In this case, the only thing that is going to change in the model is our aggregate expenditure function. The 45-degree production function, remember that is showing those possible areas where equilibrium can occur. That's not going to change because our scale is $1 on each side. So we've already seen an increase in spending. What would a decrease in spending look like? Just to do it quickly. We would just take our aggregate expenditure function and shift it down. And you'll notice that that would put pressure on Y to fall from Y1 to Y2. We've never really seen that. Again, the data just doesn't show that either one of those are true. If you look at spending over time, it's always gone up. If you look at GDP over time, it's always gone up. But again, if we wanted to show it, we could in this model. Okay, so the last thing that I really want to do on this model before we start using it to derive some of our other functions is do a little bit of the math associated with this model. So it dawned on me as I was making these that while we're really missing out on some of the class activities and practices that we kind of worked through together as a class, because most of them I just type up, honestly, right before class and print out. And I think that's something that we utilize to kind of help pace ourselves pretty well. And so I thought we would kind of put that in. So what we're going to do is I'm going to type up a practice, and we're going to try the practice out and then kind of go from there. So.